So good morning to all. So this is Selumar from SNS College of Technology and Department of Computer Engineering. So now I'm going to tell about memory management introduction. So in the memory management we have a background and swapping and condition allocation and segmentation and paging and the structure of page tables. So what is memory management unit? So in the memory management unit, so we have a program must be into memory and placed within the process of it to be run. So in a main memory, the registers are only storage a CPU can access directly. So in a main memory is the one of the concept to store all the data files and consider data files, and the virtual memory is it is a secondary memory, so it is directly shown region using files. So we can update the we can update the regional user files. It is also automatically updated in the physical main memory files. So the main memory can take many cycles and it is causing a stall and a cache. So it is required to ensure correct operations. So in every memory management unit we have a base and limit address registers. If it defines the logical address phase, and the CPU must check every memory's access generated in a user mode to be sure it is between base and limit for the users. So a pair of base and limit registers is very important for every physical memory. So in this diagram we have a 25 lakhs 25,000 to 22 lakhs 56,000 to 1 lakh 10 lakh 1 lakh 24,000 are to the main memory. So the base is 3 lakhs 40,000 for 40 and 1 lakh 20,900 is a limit. So in between we have to use the we have to store the data. So this is a hardware address protection. We have a CPU and main memory. So in between the CPU and main memory we have a base and limit address. So it worked like we have to send the address from a memory. The CPU contain address. It is check the base address, even whether it is a greater than or equal to. If the greater than or equal to means the address is sent to the limit, then the base and limit address are added to the and then sent to the main memory. If not means then it is creating the addressing error. So programs on disk and ready to be blocked into memory to execute from an input queue. So without support, this must be loaded into address 0000. So whether the address represented in different ways in a different stage of a program's life. For example, source code address usually symbolic, and a compiled code address bind to relocatable addresses, and a linker loader will bind relocatable addresses to absolute addresses, and each binding maps and one address space is another. So address binding of instruction and data to memory addresses and can happen at three different stages. So we have a compile time and a load time and execution time. So in a compile time, if a memory location known prior absolute code and can be generated, must be a recompile code if a starting location changes. So it is a load time means it must generate a relocatable code if a memory location is not known at a compile time. And execution time, so blinding delayed until runtime if the process can be moved during it is execution from one memory segment to another. So it needs hardware support for address maps, example base and limit registers. So this is the main memory management unit process. So in a memory management we have first a source programs, and it is directly moved to the compiler and assembler, and the next one is directly moved to the object and create the object module, and then related to the linkage editor. So the linkage editor is directly load modules, and the loader will send to the main memory binary memory and its images. So we have a compile time and load time and execution on the right side mentioned. So in a main memory we have used a different logical address and physical address. So the concept of logical address space that is bounded to a separate physical address space. So it's a central to proper memory management. So in a logical address it is generated by the CPU. So it's also referred to the virtual address space. So physical address, the address is seen by the memory unit. So this is the difference between logical and address space. And the logical and physical addresses are the same in compile time and the load time. So addressing blinding schemes and the logical and the physical addresses differ in execution time and the address blinding schemes. So in a logical address space is the set of all logical addresses generated by a program, and a physical address space means it's a set of all physical addresses generated by a program. This is the main concept of memory management unit. So in a memory management unit, it is a hardware device that run times maps and virtual to physical addresses, and many methods possible for covered in the rest of these chapters. To start to consider a simple scheme, so where the value in the relocation register is added to every address and it is generated by a user process at the time, and it is sent to the memory. So this base register is now called as a relocation register. So the user program deals with the logical addresses, so it never sees the real physical address, because the execution time binding occurs when reference is made to a location in memory. So logical address is bound to a physical addresses. So this is a dynamic relocation using a relocation register. So in this routines not able to until it is called. So in this CPU and main memory, so CPU contain logical address called as a 346. The physical address contains a 14,000 relocation register. So after it is stored in the memory as like as a 14,000 3046. This is the relocation register. So the no special support from the operating system is required for implementing the through program design, or OS can help to providing libraries to implement the dynamic loading and relocation registers. So this is all about introduction about memory management. So remaining we'll see in the next lectures. Thank you.